Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. This video, we are going to dive into DSPy optimizers. Can you tell me about the DSPy optimizers and different types? If you look at the DSPy documentation, you will find that there are four major types of optimizers: automatic few shots, automatic instruction, automatic fine tuning, and program transformation. These are the four types of major optimizers, and under them there are sub classes that has been created. So the classes are Python classes here: the LabeledFewshot class, Bootstrap Fewshots, Bootstrap Fewshots with RandomSearch, Bootstrap Fewshots with Optuna, signature optimizer, and Bootstrap FineTune, KNNFew Shot. Okay, what these optimizers do, why there are so many different types of optimizers. First thing, these optimizers that you see as few shots, what these do is they actually attach the examples or demonstrations. DSPy calls them as demonstrations. It attaches the demonstrations to the prompt and then it feeds to the large language model or to the program that is generated inside the DSPy modules, and then generates the output. So I'll be showing you some of the examples, and that will help you to get the intuition out of it. Next we have, just give me a second. Next we have signature optimizers. These optimizers are going to modify the signatures that we provide to the modules. If you guys have seen my earlier videos on signatures on modules, those are very important. So kindly go through those videos before you start this particular discussion, because this video is kind of a final video where you use all the parts of the DSPy library, and then try to make it come together. So that is a kind of a video that you are going to see. And this is Bootstrap FineTune. This particular optimizer helps to directly fine-tune smaller language models and open source language models using the data that we get from larger language models and more accurate language models. That is how the Bootstrap FineTune works. And KNNFew Shot I have not fully reviewed. I'll be honest with you. KNN and Ensemble I have not reviewed it. If you go to this particular category, you will see the various optimizers available. Apart from that, also apart from this API category optimizers, you will also see the optimizers details are available in the deep dive, teleprompter, and Bootstrap Fewshot. So under the teleprompter, you will also find all the optimizer details. So why teleprompter? Initially, when the DSPy library was created, optimizers were called as teleprompters. There was a reason for this. It was optimizing the prompts and the demonstrations from the distance. It was not directly connecting with the language model or modifying this parameters inside the language model. So it was called teleprompters. But now it's kind of optimizing the parameters, optimizing the examples. So they have started to call it as optimizers. Fine. So this is a brief introduction. And now what you're going to do is we are going to go back to the documentation. So if you go back to the documentation and if you click on these optimizers, you will see these are the optimizers that is right now present inside the documentation, and you can review the implementation also. A kind of implementation, you can look at it and you can see the methods, you can look at the parameters, and also kind of basic examples they also share. You can take a look at these examples: the LabeledFewshot, the Bootstrap Fewshot. Apart from that, we have Bootstrap FineTune. So all these things have various kinds of parameters and also following examples. If you go back to the main documentation and if you go into the deep dive, so you will be seeing two different locations to actually get at the teleprompters. There is only two teleprompter here. So if you see Bootstrap Fewshot is there and signature optimizer is there. But if you go to the deep dive API optimizers, there you will see all these optimizers. So you have to be you have to go to both of the links to understand the optimizers completely. My intention is not to follow this documentation as such. So what I have done is I will be going through 2 to 3 example optimizers, and I will show you how the optimizers actually work. I'll be showing you the inspection history of the language models. I'll be discussing how the signatures are getting modified, etc. So with that said, let us go to the code execution right now. I'll be importing the OpenAI SDK and getting that instantiated. Next, I'll be importing all this classes from DSPy directly, OpenAI settings, module, chain of thought, etc. I'll be using chain of thought in a couple of places here. We'll be using datasets extensively in this discussion. We'll be using both GSM 8K as well as the hotpot QA. We'll be using the evaluate class from the DSPy evaluate, and we'll be using various teleprompters. So in this discussion, Bootstrap Fewshot as well as LabeledFewshot and a brief introduction to the signature optimizer is also done in this video. And so I'm also going to show the code that is present for various classes and various functions that we are going to import using the inspect module that is present in Python. Fine. So here I am I have created an object, the TBO mod object that connects with the OpenAI, and then I have configured it into the DSPy environment. Without this particular step, what will happen is the DSPy environment will automatically create a OpenAI connectivity, and then it will start talking with that OpenAI ChatGPT API. So all you need to do is complete this step. So if you give the OpenAI API key here, it will do it automatically. So this can kind of create a confusion to you. You have to create the model object, the language model object, and then configure it. That will be better. I will be also showing you how to look at the configurations in a couple of minutes as we go down. I'm pulling the GSM 8K dataset here. I'm also pulling the hotpot QA dataset. So you can see GSM DS is the dataset object and HPQA_DS is the hotpot QA dataset object. So you can see in case of GSM 3K, the question is more into mathematical logical reasoning, and the answer is usually a number. So the metric of GSM 3K, which we'll dive into in detail in a couple of minutes, the GSM 8K metric is what we'll be using for checking the model output. So let us move forward. Here is where the power of the DSPy comes in. Here, you can see that we are creating a class here. So people who are from Python background will be aware that what is happening here, but in fact I will go through step by step. So we are creating a class called COT chain of thought, and I'm initializing this class with chain of thought class that is already present inside DSPy, and to this chain of thought I'm giving the signature question separator answer. So this is what I'm doing, and in the forward method that is part of the COT class, what I'm doing is I am using this program, and I'm sending the question that I'm getting from here. So what exactly happens? So let me explain. Once you run this class, you will be able to create the class object. So here I have created the COT_BL. So this is the baseline class, the baseline program. From now on, whatever object that I create using this kind of class, which is inheriting module, you can see that this is the class name and this is the module that is getting inherited from DSPy. If I am going to create object of any such a class, I'll be calling it as program. So in this case, COT_BL is the program that the DSPy has created. So this is the program. Why I am calling it as a program? The reason is this step where you are seeing under the init method, I can call various other modules also, various other modules also. In that case, what will happen is it will be a series of steps that the outputs from one module, that is one chain of thought module or one predict module, will be moved into the next module automatically once you call the forward method in this class. This is very similar to PyTorch architecture. If you guys have reviewed the PyTorch library, then there is a playlist on that also in my YouTube channel. Take a look at that. You will see that the forward method actually pushes this question or this variable data into the all the parts of the program. So that's why we call it as program here. And here we are going to now look at the GSM 8K metric. So I'm using inspect get source. That's what I'm doing. And if you execute it, you will see that I'm getting a very simple looking metric, right? I'm just checking equality of something. And the equality that I'm checking is of two answers. So gold answer with prediction answer. So the gold and the prediction both I am going to send it through the GSM 8K metric. But okay, what is parse integer answer? We can look at that also. I mean, I can actually click on this, and if I press F12 in VS Code, it will go to that particular function itself inside VS Code. And if I again press F12 on parse, if I press again F12 on parse integer, it will go to this particular function that has been written. But it is always better to have the discussion in a single page. So that's why I have pulled the code of these functions into the Jupyter notebook itself. So you guys don't need to actually jump and look at the code elsewhere. So this parse integer answer is, it takes the answer and parses it into integer. So that's what this particular parse integer answer is doing. And then once that is parsing is done, after that the metric GSM 8K metric is just checking whether the gold answer and the pred answer is same. I mean, it's whether it is equal. So that's what this metric does. Understanding the metric is very, very important, or else you will not understand how this evaluate is working. You guys can take a look at my earlier videos on that. I have discussed this in detail, both the dataset as well as the metrics. Here I am creating a simple dev evaluator, and for the dev evaluator I am using the dev_10 dataset. So that's what I am doing here. And once the dev evaluator is done, I am going to send and use the dev evaluator on the COT baseline. So this COT baseline program that I created. So you see, I'm going to call this as program from now on. Excuse me. Sorry about the break. We can look at the outputs directly in the, we can look at the code directly in the Jupyter notebook itself. So now you know what these functions are doing. Let's continue further. Here I am, excuse me. Here the dataset is converted, and the inputs are provided using the with inputs, so that the label and the inputs can be demarcated. And then I'm going to create an evaluate object. So that's called as dev evaluator. And I'm going to run the evaluator on the baseline COT, that is the chain of thought program that I created right now. Once I run the baseline, what happens is I can see only 50% of the answer is correct. That's what you are seeing. The average metric that I get out of this is only 5 out of 10. So the OpenAI 3.5 Turbo is getting 5 answers wrong. How can we improve this? Or can we even try and improve that? One of the methods that we can use is by using the optimizers. But before we dive into the implementing process, we have to first of all look at the inspection history. So before you try and look at the inspection history, first of all try to check how many calls has been done. So in order to check that, you can look at the object, that is the language model object dot history. So this will give the number of calls that has been done to the OpenAI API. It should be 10 or 11 here. And then you can do the inspect history method. So I am calling all the 11 outputs. So you can take a look at it here. So what has happened is, here the prompt, the signature that we are given, we have given the question, and the reasoning is it goes like this. Let's think step by step, and the answer has been provided. And most of the fields, most of the calls are done using a very basic calls. There is no any addition here. So the prompts are what the program creates. The prompts are directly what the program creates. So go up, and the program is going to create the prompts using this chain of thought module, and the chain of thought module is going to use the question as input and answer as output. That's what you're seeing here. Nothing fancy, no additional step here. What we are going to see next is what makes the things more interesting. In order to do the optimization, we are going to use some first Bootstrap Fewshot. I initially started working on Bootstrap Fewshot, and then I realized that okay, we should have tried LabeledFewshot first. Here, as I was thinking, but anyway, what I had done was initially I looked into Bootstrap Fewshot, and the Bootstrap Fewshot had two main parameters. One is the max labeled demos, and another is max bootstrap demo. Basically, the label demo takes the data from the train dataset that you provide or the validation dataset that you provide, and the bootstrap demos is something more interesting. The model itself tries to generate the demos based on the data that it is provided to it. So the bootstrap demo is kind of a data that comes from the ChatGPT or the bigger model that you are working with. So how can you find the difference? In order to find the difference, what we are going to do is, first of all, we have to save the basic baseline program. So in order to save the baseline program, after you create the baseline program, you can actually call the save method. So you have to call the save method, and you have to give a file name. So this is the file name. This is the baseline.json that I have created. And just a second. In case of the baseline.json file that has been saved, this is the model, the program file that gets saved. You can see that the demos, the train, and the traces are all empty. And you can see the signature here. So this is the signature that we provide to the program. So that is what you are seeing here. Let us go back. Moving forward, I'm going to create a train dataset also. After I create the train dataset, I am going to call the optimizer. The optimizer I have already prepared. So if you go up, I have prepared the optimizer here. To the optimizer, I have given the metric. So this metric I already explained to you what is this doing. And I have given 8 bootstrap demos and 8 label demos. So this is what I'm doing it to this optimizer. In case of the optimizer, once it is enabled, you can, once it is instantiated, you can go down, you can scroll down, and you can use that to compile. Once you compile it, what happens is, excuse me, sorry about that, just a minute. So once you compile it, what basically happens is multiple calls are sent to the OpenAI API, and there the train dataset that you are sending it is along, and also the validation dataset is also sent along with it, and the compilation process starts. So what is a compilation process? What is the output of it? So once you complete this compilation process, you will see that there are additional some 9 to 10 calls that has been made to the OpenAI. You can see the history here. And if you look at the inspect history right now, and to your surprise, the prompt would have been completely modified. So the prompt will contain these few short examples that has been attached to it. So in the initial prompts that you saw before actually compiling, you saw that only this particular format was provided. After this, none of these things were there. Okay. And if you count it, there will be 8 of it. None of these things were there. After this, immediately the question and the reasoning comes up, and the answer was provided. But now the compilation process adds these things for you. It is done automatically. And what is the idea behind this is that you are automatically adding few shots of examples to the prompt that you are sending to the model, and expecting the model to do better by giving these few shots examples. So that's what the optimization is about. Initially, the signature does not contain the few shots. But after you after you send it through the optimizer, this particular step where you are where you are actually using this optim.compile, that time this process happens. So this automation process is what we are talking about, and you can think about various locations where you can use these kinds of idea. You might have very different kind of a task or a target that you want to achieve, and you might have less number of samples, but the same samples can be used to generate additional samples when you use the max bootstrap option that I discussed right now. So you are not sitting and creating more samples or more examples. It is done for you by the large language model. How cool is that? That is what we call it as automation, right? If it is going to be a single line of question, or multi-line of questions for that matter, and single or 2 line of answer, it's okay. Maybe you can create 10 or 20 or even 100 samples, but after that you have to leverage it somehow and create more samples, right? That is where this idea comes in. And there are varieties of options where the labeled and the bootstrap demos are mixed and matched inside the optimizer, various optimizers that you see. I am not delved into the code here because the code is much more complex. It's not like the modules. The modules code was pretty straightforward, but optimizer's code involves a lot of calls, lots of loops, as well as function calls to the OpenAI. It will be way more complex to discuss that. But this discussion is already done in the DSPy paper, as well as the code base. If you go to the DSPy GitHub repo, that you can go through this particular link. You can go to that repo from here, and you can review the code by yourself. So you can go here, and if you go into DSPy, and let me zoom in a bit so that you guys can see it better. And from there, you can go into the teleprompt, and in the teleprompt, you will have all this kinds of optimizers that you see here. You can look at the fine-tune. I'm just taking an example. I'm trying to dive into it, and you can review the code. The code is straightforward. It is provided with lots of clear explanation and comments also. So but most important point is you should know basics of how the fine-tuning works, or how the optimization works, and how Python basically operates. All these things are basic requirement. Let's go back to the code that we are discussing. Now we have seen how the Bootstrap Fewshots work. After looking at that, you have to compile this. So if you look at the compiled cot.json, which is present here, I have already saved it. You will see that the demos have been updated here. So whenever you are going to use this particular program, that is a compiled program, the compiled program will come along with these demos. So what this means is, if you are going to use this compiled program, and if you are going to make a call, if you are going to give it a new question, and if you are going to ask for an answer, all these values, or all these demos will be attached as Fewshots examples, and then it will be sent to the OpenAI endpoint. So in this way, the output that you get from this particular compiled COT will be better than what you get from the uncompiled, that is without having the demos. So the baseline does not have the demos, and the compiled COT has the demos. So that's what we call it as optimization in this case. So I believe that you understood the magic is actually not magic. You need to understand what exactly changes between the optimizers and optimizer compilation and before optimizer compilation. So now I think that you have got an idea. Next, what I'm going to do is I'm going to create a new object, new language model object, and I'm going to configure that with the new with the DSPy settings. You can take a look at the new language model object. This is located at this particular address. Why I'm showing this? Because I want you guys to look at the settings.config. The settings.config in DSPy will tell you which language model is being used. The reason why I'm showing this is that in the earlier case, when I was showing the example of the COT program compilation, I was using TBO mod language model object, and I was looking at the inspection history of that. But now I want to do something else, and I need to have a clean language model object, or else what will happen is there will be lots of history and it will be difficult to follow. So that's why I create this new TBO mod language model object, and I'm showing you how to attach it to the DSPy environment. And you can see the history of new TBO mod is 0. You can see I have shown how the Bootstrap Fewshot works. You can read through this. It's not straightforward. Believe me, it's better to look at what happens. And first of all, you need to think, okay, this might be happening, and then you need to look at it and you need to try to find out the difference. That is how I try to come up with these kinds of understanding. Even though I read the process of Bootstrap Fewshot, how it is working, when you look at it, you will actually get it in an easier fashion. So you can read through this process. Now what I'm doing is I'm just using a LabeledFewshot. So this is a most basic optimizer available. And what the LabeledFewshot does is it does not generate any additional samples, but use the samples that you provide. There is no bootstrap samples. It is a simple, straightforward samples that you provide is used as demonstrations to the language model. So what happens is I'm going to use the same COT baseline and I'm going to compile it. In this time, it is not going to call any of the endpoints. It's not going to call the OpenAI endpoints. After you compile this, I am compiling it with train_10 dataset, and the dataset contains these data points. After compilation, I am saving it to labeled_fs.json. So this is the compilation process. Take a look at this. The result from 40 item, Bridget counted 14 shootings, the average score, Nancy brought, Megan Pace, Amaya scored. So these are the various questions, right? Let me actually do a print of this so that you guys can see a better output. And just give me a second, let it run so that you can, now you can see that these are the questions, and the color is a little bit different, but you can see the questions and the answers here. Okay, so the answer is here. It is all numbers. The answers are all numbers and the questions. If you go to the labeled JSON file, you'll see that a third of the contestants. So the demo has been updated. This has got demos and it has got the same instructions. Only thing is the demos are from the trained dataset that we provided. And how many demos are taken? 1, 2, 3, and 4 demos. And these 4 demos are what I told to take by telling to the model that k equal to 4. So this is what happens. So if I say k equal to 10, and if I do execute this, and if I again run this save method, let me do that just for you guys to see what happens. I'm going to create this file again with a new name. Just give me a second. And now you will see that there are more data points or demonstrations inside the labeled fs01 JSON. So this is how the compilation works. So this is what the DSPy is calling it as optimization or compilation, whichever way you call. Basically, they are going to use these as Fewshots examples, and they are going to send it to the language model when you call it with your new question. And the idea behind this is that when you are going to give few shots of examples, the language model is going to give you a better output. So that's the idea behind this. So let me close these things so that we can concentrate on and get a better output. So let us go back. So we have seen the Bootstrap Fewshot and the LabeledFewshot, and these things are adding few shots of demonstrations or examples to the language model. Now what we are going to do is we are going to go little further, and we are going to check whether the optimized program is any better. But optimized program is also not any better in this case. At least it's not giving a better output. It's still getting 5 answers wrong. Using the few shots is not working here. In that case, then what we can do is we have to modify the signature that we are giving. So these are all various ways of optimizing, and sometimes the model themselves may not have the sufficient amount of background knowledge. At that time, you might have to give your own context, and you have to improve that context also. Moreover, you can right now you can see that we are working with the same OpenAI ChatGPT 3.5 Turbo. I'm not using any of the latest models. I'm using the very old model. The output of this model is not getting better at all. This also can tell you that, okay, you might have to change the model itself. So these kinds of decisions you can very easily make once you have this kind of measurement, right? So you can look at the inspect history here after you are using the TBO mod. And once you look at the history right now, you'll see that all the history contains the data itself. So data that we are sending as examples. So that is part of it. And why this data is coming as part of it? Because I have tried to evaluate it. So go up here. I've used the dev evaluator and I've sent the COTFS, that is the optimized program. I've used that optimized program and I have tried to test it. So that is why you see the call has been done. And whenever the call has been done, it is called with 4 demonstrations. So 1, 2, 3, 4 demonstrations are called, and using the demonstrations or few shots or examples, the answer is expected, answer is requested. So I believe that you guys got an idea from this. Next, what you are going to do is we can take a look at something called a signature optimizer. So a signature is something that you provided on the top of the signature class. So what I mean by that? So first of all, we are going to import all this classes, and this is the COT signature that we are going to use. And this part, you see, this is a signature, not this one. We are not talking about this one. Okay, this is the main signature which we are going to send to the language model and instructing it, answer the question and give the reasoning for the same. So this is what we are expecting to be modified. Okay, and the COT pipeline, we are going to use a COT signature here, and we are going to call the signature into the chain of thought. So that's how we are doing it. And then we are going to call the output into prediction, and we are going to return it. So that's how it is happening. If you guys are new to DSPy, kindly take a look at the earlier videos to understand what is going on here. It will be much easier for you guys. And then we are trying to validate it. So we are going to use the evaluator class, and we are going to evaluate the COT pipeline. And if you take a look at the new baseline JSON, so let me open that. The new baseline JSON has the answer the question and give the reasoning for the same. So this is same as what you saw in this location. That's what I was calling it a signature, right? Answer the question and give the reasoning for the same. So this is what you are seeing. And then you are going to follow the same thing. So you are going to do the evaluation, and you can see the checking here. I'm checking the COT new BL program, and I am giving it the question that how many eggs will be there if 5 are taken from a tray that contain 15. Answer is 10, right? And you can see the answer is 10 and the reasoning is also provided. After that, you can use the dev_10 dataset and you can evaluate it. So when I run this code, it will start evaluating on the new program. But in this case, when I am trying to work with the COT new BL, it actually errored out. I am still trying to find out the root cause of the error, but I think it is some kind of a code error that is present in the code base. So that's why it was not working. But the idea that we are going to learn is very important. So that's why I'm going to proceed. Even though this errored out, I'm going to proceed. The signature optimizer that you are going to use here is going to use this validate context and answer function, and it is going to optimize it. It is going to optimize the signature itself. Once you call the so here the signature optimizer is called, and the teleprompter object is created out of it, and we are going to call the compile here. Once you do the compilation, it actually tells that you can modify the signature into a different format or a different set of words. So it provides the signature words itself. So how is that being done? The signature optimizer, this particular object, contains these instructions. So it is telling that we are telling to the ChatGPT endpoint that you are an instruction optimizer for large language models, and you can modify the signature. We are actually telling it to be creative. And also we are actually telling it to generate instructions, multiple instructions given the atoms. So like this, the code inside the optimizer, excuse me, the code inside the optimizer contains the signatures that is sent to the OpenAI ChatGPT endpoints, and there they are optimized and returned back. So this is a different level of automation on the signatures. So the prompt itself gets modified. So this is what I was talking about. The optimization, the prompt engineering is completely automated, but you need to understand what is getting modified. You need to understand what we are asking the model to do. Without this understanding, if you are going to use it on a very small language model which is not properly trained, then it's not going to work. You need to have a very good model. As you already seen in this discussions, I'm using a ChatGPT 3.5 Turbo. I am not at all using GPT-4. There is a reason for it. I want you guys to see what does not work. And then when you are practicing it, you can try to take and use it on GPT-4 or a bigger Claude model, any of the open source models, or you can use the Gemma model and try with Olama, and there you will find a better output. So that's the intention of showing you these things. The process of I have shown you already, explained already the signature optimizer process, and I've explained to you how it is being done using the prompts. The same steps are shown here. The starting point, use a basic generate instruction and create initial optimized instructions. It goes into iterative improvement. It repeats the optimization by evaluation and proposing new optimized instruction. And after that, after a set of iterations, you get a converged optimized instruction. So you see there is a flowchart that is provided by the DSPy guys to understand this particular step of signature optimizer. So in this discussion, we have actually reviewed the optimizers or teleprompters. We looked at the Bootstrap Fewshot. Just a minute. We looked at the LabeledFewshot. We looked at Bootstrap Fewshot. We then looked at the signature optimizers in this discussion. The rest of the optimizers I have not tested. I wanted to actually work on Bootstrap FineTune. I am planning to review that in a couple of days, and I might actually update a new video. Let's go back to the main discussion right now. So we have seen right now about how the optimizers work, what are they actually optimizing, how the prompt automation happens, what exactly is the prompt automation that is being done. All these things we saw with examples, and we also saw that by using simple Python classes and signatures like what you saw here, you can do a lot of stuff and get the things done in a way more easier fashion. So with that said, I would like you guys to take this notebook. This notebook that you are seeing here contains, just a second, the notebook. If you start from the beginning, from the top, you will see the entire series of videos that I have created till now, almost 6 videos. All the code is present in single video. From basic example of DSPy, I start introducing the DSPy code execution. I discuss the DSPy signatures. Then I follow that by executing the DSPy signatures in this series of cells. And then I discuss on these DSPy modules. Following that, I introduce the various modules here and I execute the modules here. Following that, I introduce the examples of the data in DSPy, and the data code is executed. Following that, I introduce DSPy metrics, and the metrics code is executed here. Then comes the optimizers. So in this single video, you will see in the single notebook, you can understand all these steps that is required for you to understand the DSPy library and the modules. I mean, the important point I wanted to make here is that you don't need to jump between various tutorials to actually learn something. You need to find a way to bring everything together and then learn it with a holistic picture. So that's one of the points that I wanted to try it out in this series of discussions. So I believe that you will like this way of creating the notebooks. Do review it. It's a long notebook, but once you get used to this, then it is one of the best notebooks to work with. So with that said, I would like to leave this video with 4 words, that is practice, practice, explore, explore. See you guys. Have a great time.